All right. Moving on, we have some associations of name with the symbol. B is boron. Ne is neon. Potassium, not P, but K. Aluminum is Al. S is not sodium, but sulfur. Okay, so I put a couple of the commonly missed ones, potassium and sulfur. At least sometimes sodium is called, is written as S mistakenly. Anyway, that's the first page. Alright, so now we have a couple of scenarios, and we want to know which one best illustrates the scientific method. Alright, now as you recall, the scientific method, we have observation, we have some kind of hypothesis or idea, and we test that hypothesis, and then once we test the hypothesis, we're going to maybe look at the data or and then share the results. Okay, so that's the basic outline of the scientific method. So let's read these scenarios and see which one has those items from the method. All right, a person walks by you in a chemistry lab, and immediately you smell an unpleasant odor. After thinking what a slob they are, you notice an open bottle a short distance away, labeled T-butylamine. You know that this is a bad-smelling substance, and you conclude that the person walking by must have disturbed the air enough for you to smell the contents of the bottle. You close the bottle and go back to work. All right? Let's just read the next one, and then we'll compare them. All right. It starts out the same. A person walks by you in a chemistry lab, and immediately you smell an unpleasant odor. After thinking what a slob they are, you notice an open bottle a short distance away labeled T-butylamine. You very cautiously sniff a bit of air from near the bottle and don't notice anything. You close the bottle and gossip to your lab partner about the person with poor hygiene. Okay, so now we'll compare these. All right, what are the differences here? In this one, the person walks by and you smell the unpleasant odor and you see the bottle labeled T-butylamine. That part is the same in both. And of course you're thinking at first that they're such a slob. All right, so now you notice here in the first scenario, you know it's a bad smelling substance, and you conclude the person walking by must have disturbed the air enough to smell it. Okay, now that is a hypothesis, all right, but was there any test? No, there's no test. You just know it is a bad smelling substance, and you make the conclusion. You haven't really tested it in this scenario. All right. Down here, however, you very cautiously sniff a bit of air from the bottle, or from near the bottle. Okay, that would be a test. You're testing this hypothesis. Did that bad smell come from the bottle, or was it from the person themselves? Okay, and so there's your tests. So this is looking a little bit more like a scientific method. All right, and then we can look here. There really wasn't anything more. All right, there was a hypothesis, but no test of the hypothesis. Closed the bottle, went back to work. End of statement. Nothing more than the hypothesis. Whereas here we have a test. All right, didn't notice anything. So we didn't get the results we may have been expecting. Okay, but we got results from the test, analyzed the data, if you will, and then gossip to the lab partner about the person with poor hygiene. Okay, in other words, we shared those results. All right, the results were we didn't notice anything from the bottle, so the conclusion is, well, it must have come from the person. All right. Perhaps further investigation would prove that in fact it was from the bottle, but it's a legitimate test, and from the conclusions, or rather from the observation that there was no noticeable smell around the bottle, maybe they didn't sniff hard enough or something, they concluded that the smell was indeed from the person. And what did they do? They gossiped or shared the results with their lab partner or the people around them. All right. So scenario B is actually the one that follows best the scientific method. All right. Incidentally, with this question, I shared this question with my wife, and she thought that was a little sneaky. So she said I should give you guys a point, at least, if you put scenario A. So I said, all right, I'll do that. I'll give you a point if you put scenario A, but if you put scenario B, I'll give you both points. Just for the benefit of the doubt. You can thank my wife for that. All right, question 13. Identify whether the following units measured length, mass, or volume. Okay, so inches, pretty familiar with that. That is going to measure length. All right, microliters, liters are volume units, so that's a volume unit. Quarts, of course, we're familiar with that. That is also volume. Nanograms, grams are weight. So, this would be mass or weight, depending on the term you prefer. Metric tons, again, how heavy something is, so that would be mass. Grams, how heavy it is, that's mass. Cubic centimeters, now centimeters, you might see that and think length, but this is cubic centimeters. So that means you've got length times length times length, and that is volume. Okay. Milligrams is how heavy something is, so that is mass. Picometers, that's length. This is the pico makes it a very small length, but the meters nevertheless is a length unit. Pounds, measure of how heavy something is, so that is mass. Megaliters, again, the liters, the key unit there, volume. And tons, just like the metric tons we saw, is a measurement of how heavy something is, or its mass.